which is an experimental site where you can help co-create future ways to help us make DNS and naming policy with the community. Moving up to learn.icann.org is called iCanLearn, and this is a learning platform which is a wiki format where people can add courses on ICANN topics or seek courses at any level. New.icann.org is our new website. It is in beta. We are collecting feedback, and it is designed to welcome you depending on what point of view you bring. So whether you're a government or you're a technical person or whether you're a business, we would really welcome you to that to give us your feedback. We're on social media, we have RSS feeds, and at the top of that slide is our new GTLD website with the continual updates of what's going on in this space. And I would be very grateful, I've heard from a number of you already, but please continue to tell me ways that ICANN is making your life harder with the things that we do. Please tell me things that we're not doing that we could be doing more of. I also always enjoy hearing things that we are doing that are helpful to you. And I, in turn, am very happy to describe the ways that you and your organizations can become involved, the value proposition through contributions to our technical advisory committees, or even in the generic name supporting organization. So thank you once again for your very warm welcome and for your kind attention.
Okie dokie. So we've got another one coming up, the Interdomain Congestion talk by Matthew Lukey. This should be another good one for people to talk about here after watching the fireworks on the last round. Okay, so this is work that we've recently started at CADA involving people from MIT and from CADA. And what we're looking at is the presence of congestion at high-profile points in the network, and trying to look at this over time. So the background to this is that at the moment, the pairing disputes are manifesting as congested links. Historically, when there was a pairing dispute, one party would disconnect the other, but it seems that these days the links are just being left to run full. And there's a number of disputes now, and they're among access and content and transit, whereas historically most of the pairing disputes seem to be between transit providers themselves. And at the moment, a reasonable amount of content is carried over measurably inadequate links between access and transit networks. And the congestion on these links affects everyone and not just the parties involved in the pairing dispute. It affects all traffic going across that link, those links. So there's been a steady flow of messages to NANOG and to regulators and so on, and presumably to complaints about congestion. And the focus so far seems to be on individual links. Last week there was a post to NANOG asking about congestion between Cogent and Verizon. What we're looking at is trying to develop a method to characterize congestion, the extent of interdomain congestion, and do so over time. Our goal is to have an atlas of interdomain links, their congestion state, and to also improve transparency and some grounding of this debate. And this is very early work, and I emphasize we're seeking feedback and validation. So we have a very simple method. We have some vantage points distributed through the network, and we identify a link of potential interest between two networks ASA and ASB. So we find their border routers. What we do is we send a series of packets towards a destination that will cross that link, but we limit the packet. We ask it to time out at the near router. We send another packet and ask it to time out at the far router, and so we've collected two timestamps, two round-trip times, one from the near end of the link and one from the far end of the link. And we do so over time, and we obtain a time series. And what we discover when we do this, as many people have alluded to on NANOG, is a diurnal pattern. over time on some interconnections. So what we have here is a graph taken from a point in Boston in November 2013. The red line is the RTT to the near end of the link, and the green line is the RTT to the far end of the link. And this is 1 week. And what you see is that there is a level shift during presumably some amount of a peak time, and that on this particular graph, the level shift occurs, the duration of that is somewhere between 14 and 16 hours in this particular graph, depending on whether it's a weekday or a weekend. As to whether or not this is actually causing loss or not, the graph below it, what we do is we send a series of pings, not series of, a more frequent series of probes to the far end of the router. We send essentially one every second for about a week. And we measured how many packets we got back and what the packet drop rate was essentially. And you can see that that loss does not initially begin as the level shift occurs, but a little bit shortly after that. And then the loss rate grows as what we assume is the demand on the link increases over time. So there's a number of challenges to this. So we don't actually know what the reverse path is that's coming back to us. We don't know necessarily that the link that we're targeting for measurement is the one when we see some pattern on. We don't necessarily know that what we think is congestion is occurring on that particular link. It could be taking a different path back to our vantage point across a different interconnection. In terms of methods that we're investigating to improve our support the inferences that we're making, we're going to look into using reverse path reverse path trace routes, record route, timestamps, and tomography, and anything else that we can throw at this problem to strengthen our inferences. Another challenge that we're observing in the network is that we see for some interconnections many parallel links. In some cases we have observed 16 parallel links between two border routers. And so the natural question arises, is the congestion, is this diurnal pattern consistent over all links? We would love to have some ground truth about what happens in practice. Other challenges. The other challenge that come to mind is that if we're trying to do this over time, the internet connections themselves come and go. We need to be able to adapt to router paths that change over time. We don't necessarily know which direction the congestion or the load is on the network, but we have some ideas about how we might determine that. And of course, the messages that we're sending may queue differently from other traffic, so we might be measuring something other than traffic. But in terms of one of the motivating things, and I hope this is a reasonably compelling picture if it's true, is that we'd like to be able to plot over time what the congestion pattern looks like on different links. And so this is using historic trace routes that we have from CADA's ARC project that have happened across 3 links from an unnamed access network for the past year. And so the y-axis, what that is how long the level shift is when we infer that there is some congestion. So, and it's counted in hours. So at the start of last year, the red dot sort of peaked up at around about maybe 5 hours, and there was also some blue there around about 5 hours a day that the links seemed to be reasonably congested. But then there was a decline in the blue, and that was replaced with new congestion that wasn't observed before that on the green link. And then that one was taken away after about 2 months, and then we see now a much higher presented load on the A link and a return on the B link. But the general pattern for the red one is, of course, it's gone from around about somewhere between 4 hours a day to now it seems to be congested or full for up to 16 hours of the day. So our end goal is to have some lightweight and easily deployed method to view individual link congestion patterns. The reason why we're focusing on this rather than doing throughput is that if we want to do this for all links in a given network, then we need to be able to do this without, in a reasonable fraction of length of time without overwhelming the network, overwhelming our host. And we're seeking some feedback about validation of our congestion signals. Please talk to me. What data we should be collecting and keeping. And just a final statement that we view this as a long-term project similar to other CADA projects. So your feedback is, at this point in time, would be extremely valuable. Thanks.
Any questions? Yeah, jump up to a mic.
Can you tell us a little bit more about the when you do the RTT measurements, right? Can you tell us about the size of the selection of packet sizes that you do?
So
I'd be very interested to hear about that.
Sure, the packet sizes we're using are small packets, so just your regular traceroute size 50, 60 byte packets. So they're small packets. So we're sending small packets, not large ones.
Don Bowman, Sandvine. So 2 questions. Did you look at using ECN as a signal, like maybe getting those bits back? And the second is, I think this is a great technique. One of the problems that I ran into when I tried it is using the trace route, the ICMP, TTL exceeded. It seemed to also be correlated to CPU load on the router. So as it got busier, you sometimes got both the congestion effect and the something else. Did you look at that, or do you think that's significant for these types of routers?
Yes, so on this particular graph, we see some in both the red and the green, some spike that we assume, our guess is that this is contention for some maybe router CPU usage. In terms of whether or not this is a material impact, what we're looking at is the minimum RTTs over in a particular bucket over time. So we think if we take the minimum, then we are avoiding any of these unknowns about how long we waited in a CPU for.
Did you look at the use of ECN as a
No.
Okay. That might be an interesting one to see if you could figure out a way to use both the ECN and the TTL to get that router and only that router to say it's busy.
Yep.
Maybe.
Thank you.
Perfect. Well, our next talk is Chris talking about operators and the IETF. So I'll let him take that away. Thanks, Chris.
Good afternoon. So I'm going to tell you a little bit about a new project that we just launched at the Internet Society that we're calling Operators in the IETF. First, I wanted to just kind of introduce who we are within the Internet Society. There's a small team of us, myself, Dan York, Megan Cruz, and Jan Zors there, all from left to right, that are working on operational issues and deployment issues from the Internet Society perspective. So a big part of what we're trying to do is get you all to talk to each other more, and also to provide information and kind of distill information from first adopters of technologies down to fast followers, as well as facilitate the BCOP work that's going on in many regions, and a couple of other things. Among them now is this Operators in the IETF project. So really where this stems from is we have this dream of a perfect world, potentially, where operators actually know what's going on in the IETF enough to provide input when and where it's needed, right? So that all protocols come out fully baked and in full consciousness of operational realities. So the protocols actually work in the real world, and that the real world's reflected in new protocols and new standards that are being developed. So that operators know when they need to step in and provide input and do that. The problem is that today that's not happening to the scale that we'd like to see it, right? There are operators who participate in the IETF, but probably not enough based on the feedback that I've heard in the years that I've been going to meetings and things. A lot of operators feel that there's not enough operator input in the IETF, and a lot of operators don't participate in the IETF for one reason or another, which means that we're left with researchers, academics, vendors creating all of the standards that then we have to go deploy, or you have to go deploy in the real world. And it doesn't always sync up properly because you're not always talking. So the plan is to facilitate increased operator input into the IETF. And that doesn't mean that we want all operators that show up at NOG meetings to show up at the IETF, or that you want to waste all your time following IETF lists all the time. But we would like you to be able to provide input when and where it's needed, again. So what we're doing here is, I'm talking to you, and I really want to get information from you on why you do or do not participate in the IETF, and your thoughts on how we could increase the conversation between the IETF and operators. So we have a survey out. We're gonna listen, travel the world, talk to people, try and kind of really define the problem space and understand what all of the problems are, what all the pieces and parts are. And then towards the later part of the year, we'll analyze all those results, obviously, come back again, make sure that we understood what you said, present what you told us back to you, and then hopefully from that, formulate some plans for actual changes that could be made to make this process better, right? And I think those changes are probably going to fall into 3 categories, right? There's one side which is things that the operators and the operator groups can do to help this work better. There's going to be another bucket of things that the IETF would need to do to make things better, and there's going to be hopefully a bucket in the middle also that the Internet Society, that my team or others I work with can do to help facilitate this. But again, we won't really know all of those solutions until we can really define the problem, which is where I'm here talking to you to tell you about this opportunity. We'd really like you to fill out this online survey and also come find me in the hallways and talk to me about the IETF, what you think about the current process, why you feel your input is, welcome, not welcome, or you just can't get there to give it. So there's a survey link here. I'd like to leave that up for a little bit. Also, I believe John Curran forwarded an email to the NANOG list about this survey also when we first launched the project. So, and I'll send this out again to the NANOG mailing list after this talk. But we'd really love to hear from you. It shouldn't take very long. It's a quick little survey. It's just gathering some quick information on your level of participation and level of awareness of the IETF. And so even if it's something where you feel like you've never participated in the IETF and you have no idea what's going on there, you're exactly who we want to take this survey. We'd like to understand a little bit better what your perception is and why or why not you know the things or don't know the things you do about the IETF. I'd be happy to take any questions, but really I'd just like you to take the survey.
Lee Howard. Lee Howard, so you said on the previous slide that you will listen to what we say and message that to the IETF. How do you intend to message the IETF? Just send a message to ietf@ietf.org? Because that's the only way I know of.
Right. No, well, we plan on talking to many people at the IETF. So all the way from the IAB, the IESG, to Yari himself, to area directors, working group chairs. And we're still working that out exactly where all that communication needs to happen. I will be talking, in London. I'll be talking to people and seeing where we can get this input into, and how to synergize that. So we definitely will take this message to the IETF, and basically we'll go to the IETF leadership and trickle down from there. All right. Thank you.